Every single day, millions of tires roll across our highways until they finally wear out. What happens to them after their long journey ends? In massive recycling factories around the world, these tires get an extraordinary second life. They are reborn as rubberized asphalt. Stronger, quieter, longer-lasting roads that will pave our future. This is the untold story inside one of the planet's largest tire-to-road factories. Welcome back to Secrets Unveiled, where every mystery has a deeper story. If you want to uncover the truth, make sure you're subscribed. Every year, over 1 billion tires reach the end of their life worldwide. In the United States alone, nearly 300 million scrap tires are generated each year. If left in landfills, they become fire hazards and mosquito breeding grounds. But in this massive recycling factory, nothing is wasted. One tire's end becomes another road's beginning. The incredible transformation is about to begin. The journey starts with collection on an unimaginable scale. Millions of tires arrive every month from shops, fleets, and cities. This factory processes over 50,000 tires every single day. That equals more than 18 million tires processed every year. This is far more than simple recycling. This is engineering the perfect material for tomorrow's roads. The concept of rubber in roads started back in the 1960s. Engineer Charles H. MacDonald created the first wet process. Today, that vision has grown into a worldwide industry. What was once an experiment is now proven, trusted science. And this factory stands at the heart of the revolution. Now, let's go deep inside the process. First stop is the primary shredder, a 30-ton steel monster. Whole tires are devoured in just seconds. Steel belts and rubber are ripped into 4 to 6-inch chips. This first brutal step prepares the tire for its rebirth. Every second, dozens more tires enter the system. The transformation has officially started. Next, the steel must be completely removed. Powerful electromagnets pull out every piece of steel wire. Steel that once held cars at highway speeds is now separated. What remains is mostly pure rubber and textile. This separation is crucial for final quality. Any leftover metal would ruin the asphalt later. Now the textile fibers are removed using powerful air. Nylon and polyester cords are sucked upward. Only clean rubber granules continue forward. Precision at this stage is absolutely critical. The factory's quality control team checks everything. One clean tire at a time, the magic continues. The real magic begins in the granulation hall. Ambient grinding at room temperature preserves rubber elasticity. The rubber is cut smaller and smaller. Different mesh sizes are produced for different road uses. This crumb rubber keeps its natural flexibility. Exactly what makes roads stronger and longer lasting. Some rubber goes through cryogenic processing. Liquid nitrogen cools tires to minus 100 degrees Celsius. The frozen rubber becomes brittle and shatters into fine powder. Both ambient and cryogenic methods create perfect additives. All of it will soon strengthen our roads. The factory never stops its precision work. Every batch is rigorously tested in the on-site laboratory. Particle size, cleanliness, and moisture are checked. Nothing leaves unless it meets strict standards. This quality saves lives on our highways. Now the crumb rubber is ready for its final purpose. It's time to meet the asphalt. In the wet process, crumb rubber meets hot bitumen. At 350 to 400 degrees Fahrenheit, the reaction begins. The rubber swells and bonds with the bitumen. This creates a highly elastic, durable binder. The tire is now becoming part of the road forever. A perfect marriage of waste and engineering. In the dry process, crumb rubber mixes directly with hot aggregate. Then, liquid asphalt is sprayed in. The result in both processes is rubberized asphalt concrete. This material outperforms regular pavement dramatically. It is now ready to hit the roads. The journey from tire to road is almost complete. Rubberized asphalt roads last up to twice as long as conventional pavement. They reduce road noise by 3 to 10 decibels. They resist cracking in winter and rutting in summer. Drivers immediately notice the smoother, quieter ride. This material outperforms regular pavement in every measurable way. This is engineering at its finest. Environmentally, the impact is enormous. 1 mile of rubberized asphalt can consume rubber from over 2,000 tires. Millions of tires are diverted from landfills every year. Less waste, less pollution. Fewer raw materials are needed over the road's lifetime. The circular economy is working here in real time. This is true sustainability on an industrial scale. Real-world projects prove it works. California, Arizona, and many other states use it widely. They report 30 to 50% longer pavement life and major cost savings. Taxpayers and drivers both benefit from smoother, quieter roads. The proof is under our wheels every single day. Inside the factory, the cycle never stops. While one batch heads to the roads, the next 1 million tires are already arriving. This is the circular economy in full action. Waste of yesterday becomes infrastructure of tomorrow. The factory runs like a living system 24 hours a day. The cycle continues without pause. The real hero of this story is the rubber itself. Its natural elasticity absorbs shocks and vibrations. This prevents cracking and dramatically extends road life. Nature gave us this material in tires. Now, we are giving it back to the roads we drive every day. A perfect full circle. This is the story of human ingenuity, nature's resilience, and the circular economy of the 21st century. From waste to road, the miracle continues every single day. Drive safely. Drive consciously. The future is already paved.